Hi, this is a short video on HL7 FHIR Operations. Today we're going to cover what is a FHIR operation, how does a FHIR operation work, and where are FHIR operations specified in the HL7 standard itself. Before we jump right in, we're going to take a quick retrospective. CRUDs, create, read, update, delete or deprecate, and search. Sometimes CRUDs just isn't enough, or sometimes CRUDs will work. You can read as many times as you'd like, but sometimes there's a faster way to do things. So beyond CRUDs, there's a way to run a subroutine, if you will, or a procedure or a process on the other computer, where often the other computer is going to be a FHIR server. The other computer knows about the data and the rules, and what the client is saying in a FHIR operation is, just give me the answer. So let's look at this graphically. Over here we have a client. And perhaps this is a tablet, perhaps it's a cell phone, perhaps it's an MR scanner, which should be generating MR images, not doing FHIR reads back and forth. Over here, we have a FHIR server, probably some large system in an IT closet somewhere or on a rack-mounted system. As with anything in FHIR, over here we have a client, and it's going to create an HTTP request or an API request over to the server, and it's going to get back a response. When we're doing a FHIR operation, we're going to give it some sort of parameters. So the input is going to be as a FHIR parameters resource. It's going to be encoded that way. We're going to get the result back at the output as a parameters resource as well. But the point is that some or all of the data and the work is over here on the FHIR server. Advantages of using operations over CRUDs. Development effort. The clients don't need to understand how the server works, where the data is stored, or how to ask the server for the correct things. This results in faster client application development. Performance. Put the load on the server, not the client. Don't move the data back and forth repeatedly, and in turn, limit the number of transactions back and forth. Sometimes the network throughput can have dramatic changes in productivity. Maintenance. Clients don't need to understand the changes to a FHIR server. Ideally, the FHIR server could be updated in the background, the database could be changed out, the database software mechanism, all sorts of things can happen in the background, but the interface to the client doesn't change. The client doesn't even need to know that the FHIR server was updated. So you don't want users that look like this. So one of the things that you're going to do is that when you're looking at FHIR clients as well as FHIR servers, you're going to check the capability statement to see that they support the operations that you have decided based on your use cases that you need. That way, you don't ever need to talk to a user who looks like this. Quick segue. If you're a software developer, you're familiar with RPCs or remote procedure calls. Over here, we've switched sides. Now our client is over here on the right and our server is over here on the left. A remote procedure call is nothing more than a way for a client to execute a subroutine over here on this particular server. So it's kind of cool because over here, the client is going to say, call subroutine P given data X, Y, and Z, and maybe data A, B, and C is still sitting over here on the server. This particular network protocol is called remote procedure call or RPC transmission. And we're going to say, call the subroutine P, and server is going to respond with the answer or the result for P. If you're familiar with software, a FHIR operation is very similar in concept to a remote procedure call. So let's demystify what a FHIR operation API actually looks like. You can read this URL yourself at this point. Over here, we have the server, the base URL. This time in this example, we're going to go to the FHIR LOINC server. The type of resources which we want back in our API response, or what are we asking for? We're asking for code systems. Now, this $sign in this particular example doesn't mean that it's a composite data type. It means that we are looking for a certain type of operation, and that operation is named lookup. So we're going to say execute lookup where, and here's our parameters that we're giving to the LOINC server. We're saying that we wanted to look up a LOINC code. Okay, well, that's good, but it's good programming practices to make sure that we know that we're telling the server we know it's a LOINC code. Specifically, look up this code 2708-6. This is on the input side. On the output side, what the server is going to give us is it's going to give us all sorts of information about code 2708-6. It's going to tell us the full name, the display name, maybe there's a range of values. It's going to tell us the units of measure. So we'll get a bunch of information back about this particular code from the Link server. That's all there is to it. Just demystify what an operation API looks like. This is it. You recognize it. Let's talk a bit more about operation implementation. The HTTP verb, when we were discussing with Josh Mandel about search APIs, he mentioned that any API could be initiated with either a GET or a POST. What we were doing in most of our simple searches was we were putting the parameters directly into the API string and using an API GET in an internet browser window. As things get more and more complex, your strings for your APIs would get really long. So FHIR also supports taking all those API parameters and putting it into JSON and putting it into the request header and creating a post instead. It's the same thing. So whether we're going to put everything into the parameters on the API or we're going to create a parameters resource and it's sent as part of the HTTP request in JSON format. Similarly, the result of the operation is going to be returned in a parameters resource instance, which we get back on the HTTP response. So let's go take a look at this parameters resource and what the content is, because it's something that we haven't really talked about too much. You can go do this for yourself as well. If I look this up on the website and I go to the resources page and I select parameters resource, this is what you're going to get as the structured content. It's pretty short. As a matter of fact, it has an element named parameter, and the two main things are the parameter name and the parameter value, things that you're very familiar with. So where are the FHIR operations specified? We're going to take a look at the website itself. This is the home page of HL7 FHIR. So right now we're right here. And you'll recall that in one of the first FHIR videos that you saw that I said, yeah, there's a lot of documentation on here, but you don't really want to read this documentation page because it's not a textbook. It's a specification, and it's non-trivial to read it. You need a reason to go there. So right now we have a reason to go there. Here under RESTful API, we have a section called operations, and you can see that with the N at the symbol at the end that it's normative. What normative means is that the definition of an operation isn't going to change going forward. Whether we get into R5, R6, this definition for an operation won't change. That's a good thing. I'm going to scroll down here a bit. You should please feel free to take your time and read the entire page as a homework background exercise, but I'm going to scroll down here just a bit. A couple things to note. Number one, you don't always need input parameters. So sometimes your API is really simple because there are no input parameters, but you're able to tell the server what you want it to go do and just get the response back. Meantime, I'm going to scroll down here to section 3.2.0.4, defining an operation. An operation is defined by the context for the operation. What level are we working at? System, resource type, or resource instance. The name for the operation. So every operation has to have a unique name. It's just a text string, but it's a unique name. It has to have a list of the parameters along with their definition. And then for each of these parameters, we need the following information. We need a name for the parameter, and we need to know whether the parameter is inbound, outbound, or both. We need a data type for the parameter for the response. So this is the question, here's the answer. We need a data type for the answer. We need a search type. We need to specify whether it's part of a certain profile. And then usually there's some additional documentation on it and some additional search parameter documentation. So this is the heart of what defines an operation. Furthermore, you can extend an existing HL7 FHIR operation. So I don't want to get into that, but I just want you to know that it's possible. Back to our PowerPoint. So who can define a FHIR operation? Well, you can define a FHIR operation, but both the server and the client have to agree on what that FHIR operation is going to do, the inputs and the outputs, and the expected results. Remember the 80-20 rule. All of the operations that you might need might not be defined in FHIR. Hence, it's extensible. But as I mentioned earlier, there are quite a few FHIR operations that are already defined and specified in the standard itself. And so there's what's called an operation list. Okay, let's go take a look at the operation list. Where are we going to find that? Another tab that we haven't spent too much time on is this operations tab over here on the right. Let's go take a peek. let's start over here on the home page. I come over here, I'm going to click on operations. I come to the operations list. There are about 50, maybe 45 operations which are defined as part of FHIR. So this first set are base operations. These operations are going to work on any resource type. So whether it's patient data or whether it's some of the metadata, this base operations will work on any resource type, whether observation, composition, document, diagnostic report. We can go through and we can see that we can validate a resource. We can access its profiles, its tags, or its security labels. We can update or delete some of the profiles, tags, or security labels. And we can convert from, for example, XML to JSON or vice versa. There's even a way to graph some of these resources. But there's a whole other category of operations which can only be applied to a certain type of resource. So for example, finding codes based on certain properties of the code. Some of these operations defined by resource type will have a pipe, which in this particular example should be read as OR. And you can see that some of these will work at the full resource level or at an instance level. And there's quite a few interesting ones in here. And I strongly recommend that you take some time and go through here and look at these. While we're here though, I want to check one more thing. I'm going to click on one of these because it gives you a lot more definition. But this is what's interesting. In here, in each of these operations, you're going to see input parameters defined. The parameters have a name, they have a cardinality, so whether or not it's required or optional and how many can exist, and they have a data type. These data types you already know. It also has a list of output parameters. So here's the name of the parameter, the cardinality, and the data type. And of course, there's a description. So every operation defined in FHIR has a table like this. It's consistent, and this is where you can find the definition of the input parameters, output parameters, data types, and cardinality. It also has this statement up here. This is an idempotent operation, or it's not. We'll get into that in just a second. Let's look at code systems and value set operations real briefly because these are important. These are something we'll focus on a bit. Here are all of the different operations which can be applied to a code system resource or to a code system instance. We can look up a code, as we did in the previous example. We can validate a code, and we can actually give it as a parameter and say, so LINQ, do you know about this code, and is this being used properly? We can test subsumption, all right? What does that mean? That means, there's always two codes, code A and code B. Is this particular code subsumed, or is it at a higher level or lower level than code B within a code system? Similarly, if you're trying to determine whether or not two codes match between two different code systems, you can find the find matches operation and supply as inputs the two different codes and code systems. And as an output, you'll get back whether or not the codes matched. For value sets, you can expand a value set. And you can say, for example, give me all the different values which I can use in a report. Is it final? Is it amended? Is it preliminary? And you can also validate a term and say, is this term in a value set valid within this particular set of answers? Can I use the value of edited for report? And the answer that you're going to get back is no. The options are preliminary, amended, and final, not edited. I had to go look up this word, so I thought I would mention it because it's kind of important actually, especially because we've had several discussions on security. Is this an idempotent operation? This is a property where for certain operations whereby they can be applied multiple times without changing the result. This is from Wikipedia. Feel free to go look it up. What does this mean? This means that if you look up the definition of a code several times, the definition of the code isn't going to change no matter how many times you look it up. Conversely, if it is not an idempotent operation, apply a definition to a charge item. This is going to change the definition of a charge item. This is not something that you want just anyone to have access to. They're going to apply role-based security and say not just anyone can go change the definition of a charge item. And that's a good thing. What levels can an operation apply to? An operation can apply at the system level. For example, give me the capability statement of the entire server, or tell me which versions of FHIR this server supports. they can apply at the resource level. As I mentioned earlier, it can work on all the types of resources, or an operation can only work on a specific type of resource. For example, update a security level for a specific resource instance. Apply a VIP tag. This VIP tag is only going to work on a patient resource, and yet you could change the security label for any type of resource. So this one's a little more complex because it can either apply on all the different types of resources, or it can be specific to a certain type of resource. For example, generate a single comprehensive document. This will only work on composition type resources. Then we also get down to the instance level. An instance level is to return everything for a specific patient ID. So here's your instance. This is the server generated ID. This is your instance. Return everything for this instance. So this operation will return everything for that particular patient. Or this operation can validate one specific code. Does that code exist within that code system? I would strongly recommend that you take some time and you go back to the operations list and you look at all the different operations that exist that are defined by FHIR. For example, validate a resource. Is this resource instance complete? Add profiles, tags, or security labels to a resource. You can say add metadata. You can say delete metadata. Fetch the subset of a capability statement. Okay, there's a lot of information in a capability statement. Maybe I'm only interested on the operations that a server supports or a client supports. Fetch the subset of operations of a capability statement. Another example of an interesting operation is submit a claim for adjudication. Other examples include generate a document. So this is saying, look at all the different types of documentation for a patient, or maybe you might want to set a date range in there, or particular codes or things that are included in there for certain types of documents. But generate a document, maybe with a bunch of other API parameters, which includes all sorts of information, but generate a single document. Similarly, fetch an encounter record. So this is going to fetch everything for a specific encounter ID instance for a patient. Or maybe you want to fetch all the information, all the records for a particular patient. Maybe your use case is that your patient is being transferred for secondary care. For example, they're going to an oncology specialty hospital. But you want to send all of that information with that patient from your local community hospital to the tertiary care oncology hospital. All that you have to do is to fetch or search for that patient instance with the $everything operation. Finally, another example is search for patient matches using a master patient index. Hospital A just bought Hospital B. You now have the same patient with 2 medical record numbers, and there's not going to replace the electronic healthcare record in Hospital B anytime soon. So there's a way to use master patient index searches, and it's the $match operation to say, I know that this patient has records in another FHIR server, but I don't know the patient ID or the medical record number over there. So just do the match for me. I'm just going to give you the information that our patient, Johns Hopkins, has a server ID of this number right here. The operation given below is to query for all of the patient Johns Hopkins records. So here's the API, and you can open any internet browser and just try it and see what you get back. But prove to yourself it works. Let's recap. Operations are very powerful. The computing power far extends the computing power of a client. Operations centralize the data, so you only need to have one institution. Usually it's the expert. For example, Regan Street is going to update the LOINC code system and maintain the code system. That way the data is centralized, but more importantly, or as importantly, it's also consistent. You put the data, the load, and the logic onto the server. That makes for simpler client application development, simpler and faster. Operations use the $sign notation in the API, and they have a specific name to call the specific operation. Some operations are specified by HL7 FHIR, hence the operations list that we took a look at, and those operations are extensible, but you can add additional operations. The server support for the operations are specified in the capability statement, and don't forget that both the server and the client have to be able to use the same operation and support. And then finally, just a heads up, Not every server supports every operation. As a matter of fact, there are some FHIR servers which don't support any operation. Nonetheless, on that dreary note, I still hope that you have a great day. Thanks.